usando bem a tela do leitor. என்ன தாங்க
Hello, good morning, everyone. Thank you very much for connecting to this webinar. I trust it's going to be a very interesting hour or so. So just by way of introduction, my name is Henry Bafo, the managing partner for BigData Ghana Limited. BigData has been in existence for the past 6 years, developing data-driven solutions, and particularly in the geospatial space. And over the years, we formed some partnerships with AWS, Data Africa, and a host of other industry players. And we consider that this is the best time to present this solution that we are about deploying. And so everyone here, I trust, will find it very interesting. Concerning the fact that we are coming from a recent COVID-19 where institutions had to be forced to adapt to be able to still operate remotely, we find that keeping infrastructure, especially geospatial infrastructure, on-premise is surely something that we have to move away from. We are not predicting another COVID-19, but institutions should be capable of operating. This morning, majority of our audience are in academia, and our focus is primarily sharing knowledge on how that we can move the laboratories, the GIS laboratories, into the cloud, so that not only the Earth Science Department can benefit from this technology, but also, as we see predominantly, GIS and Earth observation featuring in the food security solutions and climate change solutions. We believe that democratizing the data and infrastructure of such laboratories for other departments to access and use them is key, and still considering the fact that things are expensive, and so we have to look at solutions that optimize and lowest cost. So that is why we have put together this morning this webinar. Somebody is going to share experience from the Digital Earth Africa perspective. You know, Digital Earth Africa is now fully managed in Africa. South Africa, I think, it's transitioned from the data cube, and then now has quite substantial clean analysis ready data on Africa. And I know they are hosted also on AWS. So we'll share his experience, and then we have also a tech person from AWS to also give us the benefit of cloud computing or moving into the cloud on AWS. We know there are other options around, but having been in the geospatial space and having been on AWS, we consider that this is one of the best infrastructures to deploy on at a cost-efficient manner. And then we'll present to you some of the ideas, some of the architecture that we have. We are considering to help some of you to be able to move to the cloud. And then we can take some questions and contributions from you. We know there are some experts also that are joining us. And so it will be very interesting to share your thoughts as well. It's a knowledge sharing platform, and we believe that everyone will live here with some new knowledge on how to take advantage of the high computing power that the cloud infrastructure offers. So thank you very much. I can see Sefat on call. Sefat is a representative from Digital Earth Africa. I think that we can, if you're presenting, you have a presentation, you can share your screen, and then you can take over. Thank you very much once again, and welcome everyone.
Thank you very much, and thanks for the introduction. Thank you for joining this session and giving me the opportunity to present something about Digital Earth Africa and the AWS ecosystem. So I am Safar Chaudhry. I am the Digital Earth Africa Platform Lead at the South African National Science Agency, SANSA. As was mentioned, and as we'll talk about just now, SANSA is the host of the Digital Earth Africa technical platform. And I just want to talk about Digital Earth Africa in general. It was established by Geoscience Australia in 2019, and its aim is to ease the use of bulk satellite imagery for decision making in the Earth observation space across the continent. It was transitioned to the African continent earlier in the year. SANSA was chosen as the host, and for the last 6 to 8 months, we've successfully hosted the platform. And the vision for DEA, or Digital Earth Africa, is to provide routine, reliable, and operational Earth observation services that lets the continental policymakers, scientists, and also even the private sector and civil society to address the vast array of social, economic, and environmental needs that can be addressed using Earth observation data, and also to develop an ecosystem which allows for new innovation in the Earth observation space on the continent, customized obviously to the needs of the continent. So the thematic areas that we focused on so far include coastal aspects, urbanization, water resources, agriculture, food security, land degradation, things that you would expect very much to be relevant for the African continent. The Digital Earth Africa technical infrastructure basically is an automated system. It's fully hosted on AWS, so it's fully cloud native from its inception. And it supports the full data workflow by connecting to the originating space agencies such as the ESA and the USGS to get Landsat and Sentinel data in analysis-ready format in modern future-proof accepted standards such as cloud-optimized geotips calls with metadata in the spatiotemporal asset catalog, or STAC format, onto the AWS cloud storage at the Cape Town region in South Africa. So all of the data that we host is hosted on the continent. And then, as was mentioned, the core of Digital Earth Africa is the Open Data Cube. The Open Data Cube is deployed in a Kubernetes cluster, also in the Cape Town region, and it exposes a number of common Open Data Cube user interfaces, such as Explorer, the Jupyter Hub Sandbox, and the Digital Earth Africa Maps. So the Digital Earth Africa Maps is the simplest user-facing application. It's just a web mapping application that lets users expose different layers from our catalog of data and then compare them, etc. And then Digital Earth Africa Explorer is a metadata exploration application that allows users to easily filter all of our 11 million odd data sets by sensor, by date, by geographic region, showing the footprints, viewing the metadata in STAC and other common formats. It's essentially a discovery tool. And then most importantly, we have the Jupyter Hub Sandbox. This is an analysis platform that allows users to run their own individual Python code on the data. Again, all of these services are free of charge. And being in the cloud is key to this offering because it allows scalability that is unprecedented, and it also allows flexibility and innovation in many other aspects, including the data pipelines, the way the data processing works on a continental scale, in a scaled fashion in reasonable times, and it also allows us to monitor and engage with our users on a much more efficient basis. So there are many applications, some of which I'll just briefly mention later, but recently, a lot of the work we've done has focused on land use and land monitoring, especially with a focus on agriculture as well as vegetation and also the evolution of coastlines. So the data sets that we use include the Landsat series dating from Landsat 5, 1984 to the present time being. So that allows us a good time history at medium resolution continentally, and is the basis of many of our products. Recently, we've also got high resolution Sentinel 2 data, the full history continentally from 2017 onwards, as well as Sentinel-1 backscatter data from 2018. In addition to that, in COG and stack format, we've imported a number of additional data sets that serve as auxiliary data sets in all of our analyses that's offered in Jupyter Hub. And this includes digital elevation models, Japanese SAR data, Schurz rainfall data, land use and land cover data sets published, the major ones published by the European Space Agency, as well as Esri and Microsoft's Planetary Computing Organization, as well as Global Manual Watch. And we're constantly updating the data sets in our platform on a continental scale. And we also work with a range of partners across the continent to understand the incorporating data sets accordingly. So the focus for today is, of course, the cloud native aspect of the platform. And as I mentioned, the core of this is a Kubernetes cluster using the Amazon Web Services EKS Kubernetes Elastic Kubernetes service. And all of the infrastructure that's deployed in the cloud to run the platform is actually hosted as infrastructure as code. So we do not really have to go into the Amazon platform. We write all of our code on GitHub and we deploy it to the cloud automatically into production and development environments. And then this really facilitates the way we develop the platform and innovate, and also the way we host the platform, because it allows us to transfer the knowledge, the technical knowledge, as well as the architecture of the platform across different teams. We have had support from international teams in Europe, in Australia, across Africa, private sector partners as well. And all of the applications that I mentioned earlier are containerized.
It is getting finished. The material. Well, yeah.
Sorry, there's some background. And being in the cloud also allows us to use powerful orchestration tools such as Argo, as well as monitoring tools such as Grafana. And these allow us to really run continental scale workloads by parallelization and wideband automatic monitoring of our processes. And this has actually enabled us in a very short period of time to develop the continental scale high resolution products that we derive from the Landsat and Sentinel data sets. To do this, we end up using a vast array of AWS services, including both relation and non-relational databases. We use Amazon's firewall and security services, DNS services. We use all forms of the file systems that Amazon offers, including, of course, S3 for storing the data. So one of the things that's crucial about the platform is that we are part of the AWS's PDS initiative, where as an in-kind contribution free of charge, they allow us to host over 3.5 petabytes of Earth observation data on S3 storage. And going forward, obviously, this amount of data is increasing because every day, in an automated fashion, we index new Sentinel and Landsat data. And all of this is crucial to the platform because Digital Earth Africa is a free platform, and that in-kind contribution is crucial to the financial operations of the organization. So in order to support this at the South African National Space Agency, we also have an AWS landing zone set up, which is an organizational overarching management structure that allows us to host Digital Earth Africa as well as other new AWS-based, cloud-based workloads that we are developing. And one of the key elements of this is the AWS Direct Connect feature, which allows our on-site ground storage to connect directly via 1 terabyte fiber connection to the AWS Cape Town region. This allows us in future, will allow us in future to very efficiently and very swiftly share all of our petabytes of data holdings to the Digital Earth Africa platform as well. And we envision this growing in the future to other partners across the continent, as well other space agencies or other significant curators of Earth observation data to really enable fast and efficient use of cloud services across the continent in the aerospace. So data would typically be hosted or shared with Sensor, and then Sensor would curate and host out, serve out the data via the AWS platform via this direct connection. So what are some of the products and services we have derived from those input data sets? We have, multiple continental scale services such as the geomedian absolute deviation. So we make geomedian layers of Landsat and Sentinel imagery per annum and biannually across the continent at full resolution, at 30 and 10 meter resolution, as per the census. We also run on Landsat the water observation from space product that assigns a water or non-water flag to every bit pixel. And of course, having data from Landsat from 1986 to the present time being allows a very long range of water observation and evolution across the continent at medium resolution. That is another important product. We also have cropland extent, where we measure the extent of cropland using Landsat imagery, as well as recently we have designed a coastlines product based on the Digital Earth Australia coastlines product that annually tracks the evolution of coastlines continentally across Africa. And many of these products are actually aimed at addressing the SDGs that we all know about. So in the Jupyter Hub environment where one can run Python-based analyses, we have 7 main topics. We have agriculture and food security, water resources and flood risk, vegetation, urbanization, land degradation, coastal marine environment, and so on and so forth. So we address over 8 SDGs. I think this is actually outdated. We have close to 100 open source notebooks that anyone can register on the platform and run and change and adapt to their needs. And of course, like I mentioned, we do support partners across the continent. So with approach for more computation or storage resources, we can cater for that. Being in the cloud, of course, that allows us to scale and cater for those needs. And of course, if we look into even our short history of 3 years, we have had impact from our products. There's been various impact across the continent in the environmental space, in the agriculture space, and there's also even been some support given to governmental entities, for example, combating illegal mining and so on and so forth. So that's all from me today. Thank you very much. Chair, back to you.
Okay, thank you very much. That was a beautiful presentation. Now, what we would do is that during these presentations, if you were able to gather any questions, you could ask it, raise your hand, and then we would identify you, and then you would ask your questions. So congratulations. We would want you guys to introduce yourself. Okay, sorry, I forgot to introduce myself. I am Jaden Mouse, and I'm speaking from BigData, and I'm a software engineer. I'll be the MC for today's program. That was robust. I'm very sorry about that. So now we'd want you guys to put in your questions for all right, without any further ado, if Mr. Shafet, you could stop sharing your screen for us now. So we're taking the next speaker. And then the next speaker is Mr. Robert Njiru from AWS. So Mr. Robert Njiru, can you please do your presentation for us? So as we wait for Mr. Robin, his office will join us shortly. We would want to, take your feedback on the presentation that Mr. Shafet did. So if anybody would gladly give us feedback on the presentation that he did as we wait for Mr. Robin.
All right, thank you very much, Jaden. I think that, the presentation was great. The presentation was great. You know, the fact that Earth observation investment has surged in the past years, and it's one of the sure ways to tackle some of these food security challenges, as well as the climate change issues, suggest that you need a robust infrastructure, and I think that's what you shared. This is a Africa continental initiative, and that is hosting and processing big volumes of data. So I'm pretty much excited for this presentation and this webinar, knowing that, with the right infrastructure in place, we can produce decision-making tools or data-driven decision-making workflows to support our government, and then also the business community. So I think that the slides will be shared somewhat for us to appreciate how that in our smaller institutions we can also leverage on AWS for similar impact. We have been accessing digital African data for some time, and the efficiency with which we are able to access the data and then also develop products using their sandbox and things suggest that that solid base, that solid IT infrastructure is key to harnessing and benefiting from the edge observation technology. So that's what my feedback or my reaction. That's what my feedback or reaction will be. And thank you very much.
Thank you very much, Mr. Henry Buffalo. That was beautiful. Okay, please, are there any more? Okay, Mr. Okwampa, Queen.
Yeah, thank you for the presentation. I think I was actually very happy that he mentioned digital Earth impact in the coastal observation space. I think it's something that I'm beginning to develop interest in. But I think the question I had to ask, Mr. Bafo mentioned about he sharing the slides with us. So I'll be looking forward to the slides so that I can make time to look at it one more time. Thank you.
Thank you very much, Mr. Philip Okwampa. Are there any more questions, please? I think we have Mr. Robin Injiru in now. So, Mr. Robin
yes, you
Injiru,
do. Let me know if you can hear me.
Yes, please, we can hear you. You'll be talking about the advantages of cloud infrastructure.
Yeah, thank you for that, and really apologies for that. I've had to join using a different device. My other device was just having a bit of a challenge. So thank you for that. My name is Robin. I'm the regional lead for the public sector team within West, East, and Central Africa for Amazon Web Services. And it's a real pleasure to be here. Thank you, BigData team, and also thank you to Sefat from Digital Earth Africa, who has done interesting work with our other teams across AWS. And my role here really is just to spend the next few minutes to talk about AWS, introduce Amazon Web Services. A few of us who are on the call. And if there are any questions or a need for a deeper dive, please feel free. I'll be happy.
And Robin, we are losing you, eh?
Jump in and do the same. I think Sam, you can move to the next slide. As Amazon
Hi,
Web Services, it's
Robin, I think you are breaking a bit, but let's see if this slide works.
Really a pleasure to be able to, from of course the retail. Yes.
Now
okay. Tell me if it's more audible now.
It's audible now.
Is it better now?
Yes.
Okay. Yes, but we missed the whole intro, so you might need to do it again. Apologies.
Okay, no problem. Thank you for that, team. Let me do that afresh. So, like I was saying, team, my name is Robin Jiru. I lead the public sector team across sub-Saharan Africa for, with the exception of South Africa. It's a real pleasure to be here this afternoon or mid-morning, depending on where you are at. And again, once again, apologies for the confusion. I think we are having a connectivity challenge, but hopefully that will not keep us from the learnings that we need to do this afternoon. That said, I will go ahead with the introductions. And I was saying as I began, thank you, BigData team. Thank you, Digital Earth Africa, who we've already done some exciting bit of work with as we went along. And then I was mentioning that Amazon, when you think about Amazon, a lot of people think about Amazon, our retail organization, online retail. But AWS is not as old as Amazon and is the cloud computing arm of Amazon. And when you think about Amazon Web Services, established in 2006, and we are actually the world's most comprehensive and broadly adopted cloud platform. We offer over 200 services from data centers and infrastructure all over the world and millions of customers. And when you think about these customers, whether you're thinking about the largest enterprises, you're thinking about fast-growing startups, you're thinking about startups that are really just forming from day one, or you're thinking about leading government agencies. the whole spectrum of this kind of customers are using AWS. I mean, as Sefat presented, a part of me was a bit nervous about coming in after him, but I'm happy that he did, because it allows me then the opportunity to come in and now refer to him on quite a number of ways. And maybe, Sam, you want to move to the next one, which then allows me to then move very quickly to, when you think about cloud computing, or what is the need behind getting into cloud computing? I'm not going to cover every single thing that is on the slide, but different customers get into cloud computing for a whole array of reasons. And I'm going to actually use the third and fourth one when I think about guessing capacity and also increasing speed and agility, using Digital Earth Africa as an example, and SANSA. Because when you think about the kind of work that they're doing, when you think about the quantities of data that they have to engage in, Sefat talked towards the end and talked about the amounts of data are just increasing. He talked about 3.5 petabytes, and he says that every single day, literally, the amount of data is increasing. Now, if you think about the traditional way of taking care of that kind of data, you as a user or as a business leader or as a technical leader needed to then have this kind of infrastructure or capacity right from the beginning. Now, what is the downside of that? Apart from, of course, spending in advance, is that it means at any one point in your business, you have a lot of idle capacity that is not being utilized. And then that's where then the benefit of the cloud comes in, when we talk about stop guessing the capacity. With cloud, again, Sefat kept talking about scaling up and scaling down. That is a definite benefit of utilizing the cloud, and in this case, the AWS cloud. And why is that important? It also means that in some cases, we've seen organizations that offer you capacity, and when you scale up, then it's appreciated, but you have no option of really scaling down. We actually have that ability, so that if your organization then needs and is driving a big data, to use the word big data, and then you have peak days or you have off-peak days, and you then need the platform that you're on to scale up and scale down, that is a big benefit of the cloud. Sefat also talked about something interesting about the various kinds of data that they have to engage in. And apart from it just being a lot, he also talked about the various qualities and the different kinds. And you therefore want a platform that enables you to be able to process all this without having to second guess and think about what we call keeping the lights on. And keeping the lights on is basically just asking, if I want to innovate, do I then need to go and buy more servers? Do I need to roll out additional infrastructure capacity within my data center? And that's what the cloud takes you away from. I'm going to come back to, for a moment now, about trading capital expenses for variable. And it really speaks about capital versus operational. And with everything that's happening, even before the current economic conditions are across the globe, everyone is trying to just save something. So everyone is trying to reduce the overall cost of just doing business. Either it's for increasing profit or to maintain shareholder value. Everyone is just trying to basically reduce the operational cost. And when you think about to pay as you go, meaning for it, this then comes as a definite benefit of the cloud. And then lastly for me is, if you're a fast growing enterprise, or you're a fast expanding maybe financial organization, or even as a government agency, you're the kind of organization that is really expanding very fast, and not necessarily within even one country. It could be a continent, it could be multiple continents. You want the kind of infrastructure that expands with you and moves as fast, and therefore infrastructure does not become a limit to the way that you want to expand. And these are just some of the benefits of cloud computing. And before we move out of this, I was then asking myself, so of course then, what then differentiates Amazon Web Services? Having said that, yes, we have what we call the benefits of the cloud, but then what in actual fact then differentiates Amazon Web Services? And as you can see on the screen, there is 6 different areas. I think I'm going to touch on probably 3 of them. Our now global group CEO, who was former CEO of Amazon Web Services, Andy Jassy, likes to quote a phrase that I'm going to quote, that there is no compression algorithm for experience. What that means is basically we were born in the cloud, have been on the cloud, continue to experiment on the cloud, and that does make a difference. When you have been on the cloud from day one in 2006, and now 16 years later, you do definitely make a difference. And therefore, when we say we are the most comprehensive and broadly adopted cloud platform, it's because not only do we have the most number of services, but from an infrastructure perspective, we also bring the broadest set of infrastructure across the globe. And it also means that even in terms of what we bring to our customers, have had the longest time with our teams innovate and continue to listen to customers on this platform. Secondly, when you think about our pricing philosophy, it's a very interesting pricing philosophy. We are the only provider that has had 115 proactive price reductions to date. What does that mean? It means if you think about pricing philosophy as a circle, the more customers we get, the infrastructure costs remain the same because the infrastructure cost is a fixed asset for us. But with more customers, and we are getting more customers every single day, it means that our infrastructure cost, which remains the same, then enables us to pass on the savings that we are able to build up and extend this to the customer. When you think about 115 proactive reductions since the year 2006, this is something that we are very keen to do. And it actually comes from, if you think about the parent company, Amazon.com, this is actually then the philosophy to ensure that we are not only customer obsessed, but it's also in the way that we price our services. Lastly, I also wanted to talk about when I think about the way that our global infrastructure, we do have the largest set of global infrastructure compared to any other provider. What does that mean? It means that when you think about having infrastructure, for us, we are a cloud computing company, and therefore our customers are keen to have us provide cloud computing services from different parts of the world. But it is important for us that we provide the most optimally and high quality service, irrespective of where that customer is. And even with the broadest set of infrastructure, it means that then we are able to reach whatever customer we need to. Fat was presenting, he referred and talked about the summit, one of our newest regions, looking back at April 2020, and that just gives you a bit of insight. Across the continent, we've continued to invest in additional infrastructure and therefore have edge locations, have announced local zones in both West and East Africa, already have what we call AWS Outpost. And all this infrastructure at the end of the day is really to ensure that our customers and your customers, if you're a provider and are on this call, are having the most optimal cloud experience. So maybe we can continue moving. And when we then think about our role, you will see that in the most recent Gartner evaluation, and this one covers both cloud infrastructure and platform services, AWS was ranked as the leader and placed highest on both axes of measurement, whether you think about completeness of vision or the ability to execute. AWS was ranked the leader in this area for the 12th year in a row, meaning that since this quadrant was built, AWS has remained the year for 12 years. And when you look at some of the organizations that are still sit in this quadrant, it starts to tell you, and when you think about when I was talking about the companies that are sitting in this quadrant, we're talking about global organizations that play in the same space. And for a company to remain a leader for the 12th year in a row, I think it speaks volumes about the continued ability to innovate, continued ability to remain visionary, and also continued ability to be trusted by the expanding list of our customers that play in this space. And therefore, even as we think about this morning's session, I think for me really is to then mention that across the continent, we have remained very, very intentional about the way that we engage with customers in various countries. And therefore, whether it is the team on the call who are all focused who are all very focused around how we engage customers in sub-Saharan Africa, or it is partners across the globe, or it is actually organizations that continue to trust us within the continent and within the key countries. Because for us as a public sector team, and I mention public sector very loosely, because when we think about public sector, we're talking about all health, all education, all NGO, NPO, that's non-governmental, non-profit, and all government. When we look at this, it means that we are engaging really strategic and national initiatives of every country. And therefore, when you think about that, whether you're talking about projects that improve the economy of a country, some like we've already been referred to as Sefard presented, or when you think about it is better engagement of citizens, or whether it is in research and education, for us, we're very excited as a public sector team. We are what we call mission driven. And for us, cloud computing really enables our customers and your customers to accelerate innovation, to remain agile, and also to optimize costs, and so that they can continuously improve their ability to achieve whatever mission they need to do as an organization. And therefore, for us, as you engage with us today, please feel free to reach out to us. Let us know any specific questions you may have for us as an organization, and we'll be happy to respond to any questions. Thank you so much.
Thank you very much, Mr. Robin Njiru. That was a beautiful presentation. And as it stands, and as they already are, as aforementioned, they are for the public sector. So if we have the public sector here, we know I know we do have them here. So you can put all your questions down, and then we can ask them later in the Q&A session. So proceeding, we have Mr. Daniel Kuma from BigData Ghana, who is going to present on the cloud-based GIT infrastructure on AWS. So can we have Mr. Daniel Kuma do the presentation?
All right, thank you so much, Jaden. I have personally thoroughly enjoyed both presentations, the one by Shafat and then also by Mr. Njiru. I believe Mr. Njiru has really exposited, he has really explained on the benefits one stands to gain from engaging with AWS infrastructure or having their applications running on AWS infrastructure. My name once again is Daniel Kuma, and I'll be presenting on virtualizing geospatial laboratories. All right, so one may ask what a geospatial infrastructure is, what does it connote? And basically, we are looking at a system of systems that interconnects people, processes, data, and technology. So all these things are coming together in the form of hardware as key components in the form of hardware, software, that is the software that is running on top of the hardware, data, that's any geospatial data or non-geospatial data that is necessary, and then people, that's people that actually have the skills to do analysis, to be able to run such applications, and then the methods that they use to get the results that they need. So all these things come together to give you a geospatial infrastructure that one is able to process data on remote sensing scale, on a larger scale, and come up with results that are beneficial to an institution or to himself or herself. I believe that Mr. Njiru did a stellar job about the benefits of cloud solutions. I'm just going to sit atop that and then speak on the benefits of a cloud-based GIT solution. So we are talking about a central authoritative data source. The representative from BigData Africa spoke about different data sources that they have, data sets that they have available for you. And these are up-to-date data that are available for usage on your end. I believe it was about 3 petabytes, and he said they keep on growing, they keep on adding. So you have access to all these things at a central location, and you are assured that it's an authoritative data source for you. Then again, you are able to simultaneously use and benefit when your GIS infrastructure is hosted in the cloud. The cloud infrastructures or AWS cloud infrastructure is built in such a way that it is able to take on more users, able to take on simultaneous use And therefore, every department of your institution is able to simultaneously use and benefit, as opposed to having an on-premise infrastructure with your own servers, with your own hardware. You realize that it is capped, that you are not able to simultaneously use at the same time. Thirdly, everybody is connected, or all users are connected to the same organizational data. So for an institution, probably a public university, you are talking about off-site students, you are talking about distance learning students, we are talking about lecturers that may not, or researchers that may not necessarily be on campus. We are talking about all branches of campuses that may not be with the main campus. How can they also benefit from any GIS deployment that probably, let's say, the geography department has? How does a branch benefit from it? From a cloud-based solution, they're able to benefit. They're able to be connected and then also benefit from organizational data. Then also, we are talking about efficient sharing of analysis, visualized results, and information. So here to any analysis, any visualized result would have to be sent probably over email or pen drives or any other means. But with a click of a button, when your GIS solution is based in the cloud, you're able to connect and share more with other research. It's sustainable. Your infrastructure is able to scale up as and when you need it. You do not need to procure new servers. Mr. Njiri did a good job at speaking about how infrastructure doesn't need to be guessed. You don't need to guess the capacity that you need. What if it is more than what you need? That's a huge percentage of ideal resources. What if it's lesser? Then you are going through that whole cost to getting new infrastructure and doing the whole setup again. But with a cloud infrastructure, it is sustainable. You are able to grow as it grows. And for peak periods, it's able to sustain you. When peak periods are out, elasticity makes sure that you are scaling back again, and then you are able to provide the best service to any user there is. Moving on, how does BigData Ghana deliver on such a GIS solution? So first of all, we understand that every client is different. We understand that the needs of every client is different. The infrastructure may differ. And therefore, we want to sit with you and have strategic planning. We want to understand what exactly your needs are. One of the beautiful things about infrastructure that's on AWS is that they cater so much for every business need. So it's highly configurable. It's able to meet whatever need that you may have. And it's customized to benefit you at the highest efficiency. So we sit down and get to understand what your needs may be. Then we develop a system infrastructure for you. What infrastructure best meets your needs according to the requirements that we had down. Then we implement, or we go through an implementation phase. You're able to put all these things together to become one whole functional system of systems for you. Post-implementation training has to do with training people from in-house to be able to manage these things for you, training people to be able to use these things. This is technology that may be new to a lot of people. People may be quite used to whatever setup is running on their personal machines. So they need to understand how things work in the cloud for them to benefit maximally. Then again, we discuss ongoing management and maintenance. Would the institution want to manage these things on their own? Would they want to have someone to manage it? Or would they want a third party to manage whatever system you have for them? So these are conversations that are coming up having to do with the delivery of the GIS solution. So we want to look at a QGIS solution that is deployed via AWS Cloud. What we have, the graphic that you have is a top level view, but for the understanding of everyone that is everyone that is a participant, we want to use a scaled down version that looks like this. So we are having 3 QGIS users, for instance. And now what we are saying is that each of these QGIS users is able to access the platform, or is able to access whatever cloud deployment we have with a password. So this is protected access that is being given to the institution. And the institution is able to determine who are able to use their resources. Then again, we are able to departmentalize. So we are having For instance, an agric department, you're having environmental science department, and every department is able to benefit from the same cloud deployment and still have that administrative overhead over whatever department that they may be in. So all these users are connected to compute power, and this compute power is serverless, which means that you are not going to be thinking about what level of processing power to procure ahead of time. We are taking out completely all guessing in capacity. Now, these three, let's take them as your processors or your processing power. Now, this is what is made available to you right now. And then on the right-hand side, you are seeing two other processors with blank infills. So these are like on standby, just for you in case your capacity increases, in case it becomes a peak period. It is able to quickly procure resources for you on demand that users don't have to wait, say 3 weeks, 3 months for a new service to come in. No, as soon as it is needed, it is procured for them. And we call that auto scaling. It is automatically scaling up. And the beauty of this auto scaling is that once the users are off or once use is lowered, it is able to elastically reduce itself back again. And then you do not pay for resources. You don't have idle resources in your system. So all in all, it's a very fantastic it's a very fantastic solution, okay, for any institution to have that did not have to guess capacity, and they also benefit from peak periods and then coming down. All right, so all these processes are being connected to a primary database. So a primary database is holding all your GIS information, is holding all the information that you may need in a geospatial environment. And this primary database is also being replicated to a secondary database, which means that whatever data is being kept here is also being replicated in another database to enable high availability. Should anything happen to the primary database, which is very rare for AWS, should anything happen to the primary database, you are quickly being transferred to a secondary database and work can continue to flow. You are not going to have to wait for the primary database to be back online, but you are quickly able to work with your secondary database. And you are assured that whatever you are working with is not going to be lost. Then you're having a storage bucket that is holding reports. We are having JSON files. You're having GeoJSON files. Any files that any of these users may have been working with is being saved also on the cloud. So you don't have situations of, say, user one's laptop got missing or user two's hard disk is corrupted, so he has lost whatever files he has been working on. All his files are safely stored in the cloud for him. And the beauty of this is that because everyone is also being connected on the cloud, user one can quickly and easily give access to whatever the documents that are his to user two or to QJ's user two to also benefit from it, to also see and then collaborate with him as well. So this is a very enhanced GIS solution that we believe that every institution can leverage upon and have the best use of it. And all this is running in a private virtual cloud environment. So this is for you and managed by you, and you have control of whatever is happening in the per institution. Every institution will have its own private cloud environment, and you are assured of how things run in there. So for the architecture that we had, let's talk about money. So we want to see the cost involved. What's the cost involved for such a cloud solution? So at peak or at 100% utilization of whatever resources that is being given for such an architecture, we are looking at somewhere $49.13 per month for each of the computing powers that are included for 3 users. Then for storage, we are having about $23 a month. Then for database, that is the GIS data itself, we're having about $175.2 per month. That is running the whole database for the GIS solution. This brings us to a total of $243.33 per month. So without having to procure any server, without having to invest into buildings, without having to do any guessing capacity, without having to do any networking on your own, the institution is having access to a fully deployed QGIS solution, and it's going for just $247 on a minimal side, about just $247 to begin with. That's something they can start off with. So we want to look at what a classic on-premise QGIS setup may look like. Say someone is having an on-premise setup, how is this going to be looking like? So the person may have, say once again, you're having 3 users, and then these are being connected to a cluster of servers that are running on-premise. So this is requiring a physical building space. So this whole setup is inside a physical building space. You are having about a number of servers, and then these servers are taking whatever requests that are coming from the QGIS user. They are doing your processing for you. And then also all the servers are connected to a central database. So this central database is holding all the GIS data that one may need. And then you're having this on-premise network configuration. So in a nutshell, this is how an on-premise solution might look like. How does this compare with a cloud solution in cost? So an on-site deployment versus a cloud deployment. So an enterprise server, you need to get an enterprise server for that level of on-site deployment since you are running virtual institutional laboratories. So they go for 4,800 to be able to do that level of processing that GIS does. Be looking at a cut of $4,800 for one server, as opposed to a cloud deployment that may be able to run, pay as you go as well. So only when you use it, that's what you are paying for $49. And this is by numbers, probably just about 1% of getting the whole server yourself. And then for storage, your storage is inherent in the enterprise server. So an on-site deployment doesn't have any cost for storage in here. But for a cloud deployment, because you're having a fully managed relational database for you, and then also having to store all your JSON files, or your raster files, or your images, reports, whatever result that may come out from analysis is being saved also in the cloud. So you are charging it adds up to a charge of about $198.20. For an on-site deployment, you need to get monitors, you need to get peripherals, you need to get a number of things that are interconnected for it to work well. So you are looking about $210. For cloud deployment, we are running it on a bring your own laptop or bring your own machine infrastructure. So there's no payment or there's no procuring of such things. For installation costs, once you are having your server, you need to get a network engineer to do all those networking for you. So say you have about 30 computers in the laboratory, to be able to connect all these computers perfectly, then do installations of the GIS software, and then also install for the databases as well. For cloud deployment, it is variable because as BigData Ghana would have to understand whether you want to do you have migrations that you want to make into the cloud, which may come at a cost, a lesser cost. And then again, if you do not have any of those, what architecture are you going to be running for you? And that influences whatever cost may come as installation. For maintenance cost, on on-site deployment, you need to have electricity running, you need to have internet, you need to maintain things that get broken down, say monitors, servers, even for servers, about 4 to 5 years, you may have to replace them. So you're talking about a lot of maintenance that is going on. This variable for your own users, but you know that there's a cost in that. And for a cloud deployment, you do not have to manage that. Once you've made your payment, AWS is taking care of all those maintenances. Then for building costs, an on-site deployment would have to run in a physical building space. So that also comes in as well as variable. For cloud deployment, you do not have any building space to cater for. So it's also at a zero. So just to get set up, on average, an on-site deployment might cost someone about $6,510. That is a steep incline to begin with. For a cloud deployment with about $247.33, you are able to start something, you are able to have a cloud deployment up and running, and you are assured that in any which case, should your usage increase or should your needs or your capacity increase, is able to scale up and manage at that level. But for an on-site deployment, should any of such happen, you know that this is new cost coming in. This is time going to be taken for all these installations as well. So we believe that a cloud deployment is of huge benefits to any institution that will want to benefit from cloud deployment, that will want to benefit from the trends that are even going on in the cloud, in the geospatial environments as well. Okay, so we want to see the value, the benefits that accrue to your institution. Your institution, we are speaking so much about the value on the whole, but to your institution, we are talking about firstly, value for money. Value for money. You are not having any guessing capacity, as Mr. Njiru spoke about. You are also taking out every capital expense and you're exchanging it for variable expense. You're having on-premise, you're having larger upfront costs. And then for an AWS cloud solution, you're having lesser upfront costs. You're only paying for what you use, and you are not having to have any idle resources because it's only when you use it that you are paying for it. Then secondly, we are looking at mobility, reach, and increased collaboration. Mr. Baffo, Mr. Henry spoke about the recent pandemic and about how so many institutions were hindered, were left out of the educational space because they had not had any infrastructure that benefits or that is able to withstand being off-site. So they had nothing remote to be able to serve the students. But once you are having a cloud deployment, you are talking about increased mobility. So wherever students may be, they are also able to access these resources and make use of them. They do not have to be physically present. They can connect securely from anywhere. And then it's available to every authorized personnel as well. Then also you're having increased collaboration. You're able to easily collaborate because everyone is on the same system. Everyone can easily be given access to whatever data is on the system. And then everyone is able to work together in order to come up with the best efficient solutions that they may have in good timing. So we really believe that we are able to extend your reach, mobility, and increase collaboration by being on the cloud. Then again, we are talking about scalability and elasticity. So resources are procured on demand. There's no guessing in this. We do not have to think about, okay, I have 100 students, how many will reach them? What if you are having 200? Does it mean you have to go through all that? No, we are having resources procured on demand for you on cloud, only when you need it. And as soon as you need it, it is also available. So quicker setup times for you. You do not have to go through all the installation of whatever QGIS or whatever GIS application that your institution uses. It is also sustainable. For a cloud solution, it is sustainable. It withstands wear and tear because AWS caters for whatever hardware, whatever infrastructure that you'll be using. AWS caters to it and allows you to focus, not doing any repetitive tasks, but focus on getting results, focus on the work that you actually came out to do. So that's about scalability and elasticity. And then lastly, disaster recovery. This is a big one. This is a really big one. The volume of data that GIS users have to engage with, have to interface with, are very huge. And then the work they do may span months, years, and whatever analysis that they may be doing, whatever work that they may have done, it's a very valuable thing. And it is very disadvantageous to have a single point of failure, to have a centralized database where should any occurrence, do not wish any such occurrence, but should any occurrence like fire, like flood, probably even gets corrupted on its own, we do not want to have to lose all that data just because of a single occurrence. So AWS cloud solutions are saying that you're having multiple points that are more resilient to whatever adverse situation, whatever adverse condition that may befall the database. You are assured that your data is always up and ready. Your data is always safe for you to be able to use on any day that you want to use it. Then one may ask that, what about some deployments that are having, for instance, an industry leader like Esri, for cloud deployments like their Arc server? What about when you buy a license in there? Now, when you buy this license, you paid an annual subscription. It's still subscription based. You paid an annual subscription. These go way over $3,000 for an annual subscription. Then you are having about 30 computers on premise. Then you are having this cloud or annual license as well. Now, whether these licenses are being used or not, you are going to have to be paying for them. You are going to have to be paying for the whole, you pay for the whole year, whether it's being used or not, the cost is already gone. Then again, because you have a physical space that these licenses are running in, you cannot scale up. So you have a lot of instances where students that may have to have a practical exam are having to come in groups. So group A comes to use the lab, then group B comes to use the lab. But for a cloud deployment, all these students are able to do their practical exam at the same time because it's able to procure for such a peak period. So the next steps are having to have a discussion in-house probably, and then contact BigData Ghana, let us understand what your needs may be, and then we can take it up from there and then move whatever resources that you may have, migrate you to the cloud, and then make you future-proof, then make you ready to face the future as an institution, and more appealing even to students to come to study at a prestigious institution. So thank you all for your time, and I believe that we would have, any questions you have, be able to address it, and I believe that we'll have a good time from here.
Thank you very much, Mr. Daniel. If you have any questions, this is the time for you to ask them. So before the presentations, we asked you to take some notes if you have any questions and put them down. And this is the perfect time for you to ask them. So if you want to ask a question, you kindly put your hand up and then you'd ask the question. Relating to all three presentations, of course.
Thank you very much. I think there was a question from Edward wanting to know about the possible packages that academic institutions can leverage for teaching and learning purposes. Yes, so maybe AWS will have a word on it because we have the public engagement team here, but from BigData, what we are saying is that's the purpose of one of the objectives of this webinar, to let you appreciate what is possible for the academic institutions and how that it can be cost efficient to deploy a GIT for student access. It is based on the requirements that we identify when we have done such engineering process. All right. So yeah, I just saw a question from Edward. Edward was asking about how academic institutions can get packages, unique packages for them. You know, that's the purpose of this webinar. One of the objectives is to allow the institutions, the public institutions, to appreciate the cost reduction and the cost efficiency in deploying in the cloud. And then conversations can begin from after such a gathering on the unique requirements of these institutions, and then we can and present it. I don't know whether, since there is a public engagement team from AWS, you will want to respond directly to the question from Tandem University of Technology.
I think our addition is this. Okay, you wanted to go, Evelyn?
No, please go ahead, Robin. Thank you.
Okay, thank you. Just wanted to thank for the question, and also just mention this, because we have a special team that focuses exclusively on education. What that means is the team is first of all comprised of people that bring in varying levels of experience in the sector, and therefore it means that whatever kind of education institution you are, we're talking everything from K-12, higher education, ed techs, ministries of education. It engages the whole spectrum of education kind of customers. And that then said is different institutions require different levels of engagement and solutions. So like I think Henry has mentioned, we are keen to first understand what is the specific need. At a very basic level, for example, we have institutions that basically just want to migrate from an on-prem previous engagement to a cloud motion. At other levels, we have institutions that now, having moved into the cloud, want to improve the trainer and student experience, and even to the level of sometimes being able to pick up on student performance halfway through a term or a semester by using various machine learning and artificial intelligence solutions. And therefore, we are keen to understand what is the specific need. So feel free to reach out to us. I think you've picked up on the various names. There's Evelyn, there's Nena, there's myself, there's Sam. Please reach out to any of us and we'll be happy to engage. Unless there's something you want to add, Evelyn, please feel free.
No, I think you hit it right on the nail.
Yeah.
Okay, there's another question in the chat session from GAP, and then he wants to know if Digital Earth, they have data to analyze water quality parameters. So if that question could be answered from Mr. Safet.
Thank you for the question. Yes, we do have data that can potentially be used to analyze water quality. One of the notebooks we have actually addresses phytoplankton blooms and algae blooms, both on a coastal and inland water environments. You're welcome to join the sandbox, the Digital Earth Africa sandbox, and have a look at that notebook. There are a few others as well. If you're interested, just drop me an email. I will forward your details. I'll put my email in the chat just now. Thank you. Hope that answers the question.
Thank you very much, Mr. Safet. I think that did. So we are still taking questions. Do we have any questions for Digital Earth Africa, cloud infrastructure, or Big Data Ghana? Okay, we have a hand up. A real quick question. You can ask your question.
Yes, I wanted to ask about the difference in cost between the on-site use of service and the AWS service, because I mean, I feel if I've paid for the setup, the initial setup, and I've got the service I need, wouldn't that be okay? Like, what are the additional benefits I would get from the AWS service as compared to just the one-time payments?
I think Mr. Daniel Kumar has to answer this question.
Well, I mean, before Daniel attempts it, I think that, I mean, from all the presenters, we have seen multiple benefits of moving to the cloud. And again, globally, I think that is the direction for all institutions using ICT technology. And I think just what Robin just mentioned, I mean, you are able to then do so much more than just host data and then use it for specific analysis. Like the example he gave, should you want to improve on, even if you were already in the cloud and you wanted to improve on what you are getting, the insights you are getting to enrich your decision making, you could easily deploy artificial intelligence over the data that is being generated with very, very little or time duration to get this up and running. And that is key. That is one of the benefits that your on-premise infrastructure may not necessarily give you. Also, there is shared responsibility. Okay, for your on-premise infrastructure, you have full responsibility for everything. I mean, whereas when you come to the cloud, there is shared responsibility. AWS has a responsibility to ensure your infrastructure is available, and depending on what you have signed on to, it can even go beyond. You know, in the architecture that Daniel presented, the RDS service allows you to just focus on making sure that your data is of the quality that you want. In terms of its availability, the responsibility whilst you're on aid of the RDS is that there is a backend team that is ensuring that your database is up and running, doing all the monitoring and all the back-end maintenance for you, so that any day your database is always available and running. You know, so the benefits are enormous. And for us at Big Data, one of the reasons why we put this webinar together is that there is a category of institutions that may be on the cloud, whether probably even on AWS or other cloud infrastructure, but may not be optimized to take advantage of the whole cloud infrastructure benefits that we are mentioning. So, for example, I mean, if most of the licenses are in the cloud, or you get your authorization from the cloud, but that does not necessarily mean that you're running on cloud infrastructure. So because once that you have paid for an annual license, what AWS is saying is that, for example, there is Esri licenses on AWS, Esri server license, and those of us who are conversant with the infrastructure, we know how much owning an AWS, owning an Esri license or Esri server license costs. However, with AWS deployment or the designs we are making reference to, you are paying just for it is a pay-as-you-go service. So you are paying only when you are utilizing these server resources. You are paying only when you are utilizing this software, this ArcGIS desktop license and all. So it's really, I like the point that Robin made. I mean, you remove the idle capacity. You know, some of the industry that we have spoken to, industry players that we have spoken to, yes, they could really afford all their staff to be on a premium license or proprietary license from AWS and from Esri. However, because of the idle capacity, the cost of paying for idle capacity, they may have just 2 or 3 licenses and then hybrid it with some open source software. You know, meanwhile, on AWS, when you come, you can surely be able to still have access to or your staff can all all be able to have access to that premium license, run the models and the analysis, or do the work that they want to do, and it will still be cheaper than it will still be cheaper than all the existing on-premise infrastructure, or even in the cloud running your licenses. So I hope Oriku answered your question. I don't know whether somebody will want to add something.
Mr. Henry has done a very good job at explaining the benefits that you stand to accrue from having the cloud deployment. I just want to add that you may actually have your own servers, but then again, you're having to manage any disaster that may befall it. Whatever data center that you'll be running is just on your own, and should anything happen, you'd have to have backups for yourself. But these are also being managed by AWS or being managed in the cloud. So you can rest assured that none of the staff can do anything shady on it. And then also it is being kept for you against whatever physical adverse conditions. So I believe that it's a good thing to have.
Thank you very much. That was a beautiful answer. I believe that we are still taking questions. If there are none, we'd have to adjourn the meeting. So we will give it a minute. So we're still taking questions. Just a minute. So if you have any questions, you can either raise your hand and then ask, or you send it through the chat and then it will be read out for you. Okay, the minute is up. Okay, so thank you all for joining this beautiful webinar. It was really nice to have all of you here. The people that are engaging us, further conversations would go on behind the scenes. And then you can all follow up on the emails that have been put up, and then things will take hold and would take on from there. And lastly too, we'd want to take a snapshot of the people that joined the meeting. So if you want to be in the snapshot, you can turn on your camera, and then on the count of 5, you'll take a snapshot.
Recorded.
So